So what is a function? A function is a special type of relation, right? So a relation tells you how certain variables are related to each other, right? So typically you think of, think back to algebra, you looked at the Cartesian coordinate system, you had ordered pairs x and y, that's a relation. Given x, what's y? How do x and y relate? So a circle is a relation, right? X squared plus y squared equals r squared. That's a relation. A function is a special type of relation. It is one in which each output, so we say y is related to x, each y, no, I'm sorry, each x goes to only one y. So each x relates to just a single y. So 2 can't, for instance, be both 3 and 5. That would not be a function. One-to-one is the y's that I'm thinking of. If you're given a graph, I shouldn't say graph, something different. If you're given a plot, there's what's known as the vertical line test. Right? Draw a vertical line on the plot. If that vertical, is it vertical? Is it horizontal? Horizontal is then one-to-one. I always confuse the two. Right, so verticals for the function. If that vertical line intersects the graph more than once, it is not a function. Right, so again, a circle is not a function. Half a circle is.
Well, depending on which way it's oriented.
The upper half or the lower half, yeah, would be a function. Well, I would argue that no matter how I orient it, it's still a function. Because if I do that, I'll just say that x is a function of y, not y a function of x.
Okay. You got me.
So I'd argue that is still a function, but that's like more advanced. Another way to think of a function is if you're given a relation. So in this case, we're given the relation y equals x squared plus 4. If you can write it in a way that y, there's only one y value for each x input, then it's a function. Well, we're done, right? There's no work that needs to be done here. Y equals x squared plus 5. Pick a value for x. You're only ever going to get one y value, right? Specifically, square the x and then add 4. So this is a function. Let's go. And again, we have another relation, x equals y squared plus 5. We're trying to solve for y, right? So subtract 5 from both sides. And remember, since equality is commutative, the order in which you write it does not matter. Right? X equals y, y equals x, they're the same thing. So now y squared is equal to x minus 5. Well, what would we do to solve for y?
Square root of both sides.
Take the square root of both sides. What is the square root of y squared?
Plus positive or negative.
It's the absolute value of y, right? -2 squared is 4. But the square root of -2 squared is +2. Because it's the square root of 4. I'm going to write it as absolute value of y. There's a reason I'm doing that intermediate step. The absolute value of y, that actually is important. But absolute value equaling something. It's the same as saying that the value itself, y, is plus or minus whatever it equals, right? So y would be plus or minus the square root of x minus 5. Keyboard needs to go away, thank you. This means x is either positive root of x minus 5 or y is the negative root of x minus 5. So if you pick any value for x, you get 2 values for y. Means it's not a function. If I say y is just the positive root of x minus 5, now it is a function. What about y equals 5? It is, right? For any value of x, you get 1 value for y. Specifically 5.
As long as you get them.
Nowhere does it say that you can't get the same value of y for multiple x's. That is a different definition. That is 1-to-1. If there's only one value. We'll discuss that later. Specifically, this is just a straight horizontal line, isn't it? X squared minus y squared equal to 36. I think this is hyperbola. I don't remember my conic sections. I think it is. Well, the idea is we want to try and solve for y. Make sure we, or see if we get just a single value for y. Add y squared, subtract 36 on both sides. Take the square root. Absolute value of y is then the square root of x squared minus 36. That means that y is x squared minus 36, or negative square root of x squared minus 36. And if you pick a value for x, you're going to get two values for y. So that is not a function. Oh dear. I'd like to be bothered. Function notation. F of x equals x squared minus 4x plus 2. Our function is denoted by f. So our function is f. This f of x is the output. The input is x. X is also called an independent variable. I want to find the following. Start with f of 5, right? So there are two common ways to look at functions. One way is to think of it as a mapping between two sets, right? So a domain into a codomain. The domain is just all the values that can be put into the function. The codomain is the set of values that come out of it. Well, the range is the set of values that come out of it. A codomain is something different. If range happens to equal codomain, then we say the function's onto, but again, that's something we'll talk about a little bit later. The other way to think of functions is as a machine. Right? So you put something into a machine does whatever it does, and it gives you an output. Right? Something comes out. So what this is saying is f of 5, we're inputting 5 into f. And we want to look, okay, so how's f going to transform this? Or based on this function mapping, what does 5 map to? Well, it's fairly straightforward. Since x is our independent variable, Everywhere you see an X, replace it with 5. I guess your pencil had enough of that, huh?
Yeah.
It's like, nope, I'm done. This is your pencil, not a calculator or a phone. So 5 squared, 25. 4 times 5 is 20, right? 25 minus 20 is 5, plus 2 is 7. So we say f of 5 is equal to 7. Same thing. Ever see an X, just replace it with -3. -3 squared, 9. -4 times -3 is 12. 9 plus 12, 21. Plus 2 is 23. F of -3 is 23. Doesn't work just for numbers. Numbers, oh dear. Numbers. It's a Monday. It's only my 3rd cup of coffee, so I'm behind. It also works for variables. Right? F of A. Where A is just some value, right? It's an arbitrarily chosen value. It's the same rule. Everywhere you see an X, replace it with A. A squared plus 4A, or plus, no. A squared minus 4A plus 2. That cannot be simplified. So just leave it. F of A plus B. Everywhere you see an X, you replace it with A plus B. That can be simplified. I know. Evil bastard, making you think back to algebra. Who remembers the formula for A plus B quantity squared?
A squared plus 2AB plus B squared.
The 4-letter F word that every algebra student hates. FOIL. This happens to be a special formula. And in fact, I have a formula that no matter what that power is, we can easily determine the expansion. Right, so even if it was like A plus B to the 6th, there's a very easy way to determine that.
Pascal's triangle.
Yeah, we're going to actually go over that. I have an example with x cubed. I'll go over Pascal's triangle and the binomial theorem. It's really nice. Distribute that 4 through, right? Actually, it's distribute a -4 through. Now, believe it or not, that is simplified, right? There's no common terms. There's only one A squared, there's only one AB, there's only one B squared, there's only one A, there's only one B, and there's only one constant. You could try and move things around. Don't have to, it's not necessary. It's just based on aesthetics at that point. right? Like one way would be if you're looking at just a general quadratic. That would be then, that is the standard form for a general quadratic. Group all of your squared terms together, right? And then all of your mixed terms, then all of your single terms, and constant at the end. But again, it doesn't matter because addition is both commutative and associative. Now, what about f of a plus f of b? Well, first, we need f of a, which we found already, right? That was what? Part C? F of b. Same thing, right? Just replace a with b. Now simplify. Plus 4, right? 2 plus 2. Nothing else can be combined because there's no other like terms. And there you go. So f of a plus b does not necessarily have to be f of a plus f of b. In the case where it is, that actually has a special name. There has to be one additional property with it. That's the idea of linearity. And there's an entire course on studying linearity called linear algebra, which is a sophomore level math course. Math majors, you have to take it. Comp Sci also has to take it. In fact, I think the only STEM field that doesn't have to take it is biology. If you're a STEM major outside of biology, you probably have to take linear algebra. It's fun. Here we're given that g of x is negative 2x squared plus 3x. We're asked to find and simplify three things. First, g of h. Not much simplification to do there. Right? Negative 2h squared plus 3h. You could technically factor an h out. It's not really simplified in my opinion. Next, we want g of x plus h. And we want negative 2, then times the quantity of x plus h squared, plus 3 times the quantity of x plus h. Right? Now I need to simplify that. First thing to do, expand out the x plus h squared. Now we already saw that with the a plus b, same thing, right? Square of the first term, square of the second term, then twice their product. Might as well distribute that 3 through. Now distribute that negative 2 through. There's no like terms, right? So just leave it like that. Finally, g of x plus h minus g of x all over h. This is a very important quantity. Does anyone know what that's called? This is called the difference quotient. Difference quotients are very important. In Calculus 1, you study a operation known as the derivative. The derivative is a limit of the difference quotient. So that's algebra. Calculus adds one extra step, and that's to take a limit. And by the way, the limit's actually the easy part. Calculus is easy. Algebra is very hard. 90% of the mistakes in my calculus courses, this is Calc 1, Calc 2, and Calc 3, are not the actual calculus itself. It's the algebra that they make mistakes on. So g of x plus h, we just found. No need to reinvent the wheel. Speaking of, instructor's prerogative. If it lets me do it. Technology is a wonderful thing. Except when it doesn't work. Minus g of x and then all over h. So this was just step one, right? Just put in what g of x plus h is, put in what g of x is. Now we're gonna have to simplify it. Be very careful. A very common mistake that I see, and again, this is not just in this course, I even see my Calc 3 and differential equation students make it. Is they do not write the parentheses. They are two completely different terms. Without the parentheses, that minus is only being applied to the first term, the negative 2x squared. That is not what the difference quotient says. It is minus all of g of x. So you either need to put parentheses around it or distribute the negative through in your head if you don't want to write parentheses. So let's go ahead and start collecting like terms. You're doing this to me. Okay. Get annoying. So let's reset you. Okay, so x squareds are like terms. We have an XH, just an XH. We have just the one H squared, right? The X terms. And then the H terms, just in the numerator. I'm ignoring the denominator for right now. Oh, look, negative 2x squared minus negative 2x squared is 0. We have a plus 3x minus a plus 3x. That's 0. But we're left with the numerator, negative 4xh minus 2h squared plus 3h. Right, and the order in which you write that doesn't matter. Well, numerator, don't we have a common term? What can we factor out? We can't factor out a 3. Well, I mean, I guess you technically can, but then we're gonna have fractions, which is no, let's not do fractions. We don't have to. In fact, out an H. Specifically, and this is preference only, I'm going to factor out a negative H. I don't like negatives. And then I look at this and I go, well, factoring out that negative isn't going to help me at all. So it's kind of pointless.
Oh, why isn't it pointless?
Because I'm not going to be left with a fraction. So I'm going to have negative and then parentheses, which looks more hideous to me.
So then distribute the negative.
Yeah, so I'll have to, yeah, but that's what I mean. So factoring out to begin with was pointless.
Oh, I see.
Because now I'm going to wind up distributing it back through.
Okay.
So then I just go like this. Okay, well, that was pointless. So I just pretend like I never did that. I go, how you can't prove a thing. I go, I'm just going to factor out an H and I'm going to rewrite the terms just so my positive's out in front. I'll go, that's 3 minus 4x minus 2h. Do you have to rewrite it? No. Again, it's all preference.
First answer would be fine.
You mean, yeah, really, even as a fraction with the H in the denominator?
Well, you have to cancel out the H.
Yeah.
I'm talking about factoring out a negative or rewriting the order. That's preference. H over H is 1. After 3 minus 4x minus 2h, technically I have to put a condition on that.
Oh, yeah.
For h not equal to 0.
Why do you have to put that?
Because if h is 0, then you have 0 over 0. Which is undefined. Right, so in other words, if h equals 0, these two terms are not equal. Right, one's undefined, the other's 3 minus 4x. They're not equal. We typically just ignore that because it's implied for h not to be 0. In calculus, the last step is to pass that through a limit as h approaches 0, which means h can't be 0. And then that would be the derivative. So actually the derivative of this function is just 3 minus 4x. And that's your calculus step. So calculus is easy. Algebra's hard. And then you might think, oh, how bad can it get? Difference quotients can get very ugly very quickly. So x cubed. We'll find the difference quotient. Just so the algebra doesn't look daunting, I typically do this in a 3-step process. Right? And if there's calculus, there would just be a 4th step added on. First thing is just find f of x plus h. X plus h cubed. So one person in here is familiar with Pascal's triangle, so I'm going to ask him, expand this out. You have 5 seconds.
Let's see here, x cubed plus 3x. Oh my God, no.
Oh, you're out of time.
Yeah, all I remember is Pascal's triangle works it out, but yeah, 3, and then there's just 6 in there, isn't there? Oh, okay. That's right.
And I'm going to show you how I got that. One of the more important results out of algebra is what's known as the binomial theorem. So for any real numbers x and y and any positive integer n, binomial theorem gives us a way to expand out x plus y to the nth power. And there actually is an extension of binomial theorem that gives you for n being negative. Well, actually being negative, you just flip it over, but for n being any rational number as well. We don't need to worry about that. Here's your first look at the language of mathematics.
That y equals 0.
I equals 0. Yeah.
Oh,
This is read n choose r. It's defined as n factorial divided by r factorial times n minus r factorial. That is the nr binomial number. That's n choose I, which is what this is. I'm choosing R instead of I for the definition. Well, that n comma R for here, right? Yeah, that's the NR binomial number. So that when you look at binomial numbers, it's technically ordered pairs for the what number it is, and then the actual value itself is a single number. So this is actually a two-variate function. That formula is actually quite a pain to work with. Now, there is technology, and a lot of calculators now actually have the binomial number function built in. So you just find the binomial command, and then you type in your n and your r, and it gives you the number. There's another way of doing it. So there's this little structure called Pascal's triangle. Forming the triangle is easy. The sides of the triangle are always 1. To find the middle terms, you just take the two elements diagonally above it and add them together. And it just keeps going. Here's the beautiful thing about Pascal's triangle. Every single number that appears in Pascal's triangle is a binomial number. It's Pascal's. So you start, top row is the 0th row. And each row, the first element is considered to be the 0th element. All right, so if I look here, 4th row, 0, 1, 2, 3, 4. So if I said 4 choose 2, you go down to the 4th row, and you move over to the second element. 4 choose 2 is 6. X plus y to the 6th power. Start your first term to the highest power. Your second term to the lowest power. So it'd be x to the 6th times y to the 0. The highest power. Right, it's being raised to the 6th power. So highest power is 6, so your first term x is to the 6th power, second term y would be the 0th power. Right, y to the 0 is just 1, right? So it's just x to the 6th. Each term subtract 1 from the power of x. I didn't give myself enough room. And add 1 to the power of y. You do that until you get to your final term, which is just y to the 6th. Notice that the sum of the powers is always equal to 6. Now for the coefficients. Go down to the 6th row of Pascal's triangle. It's what? 1, 6, 15, 20, 15, 6, 1. Those are your coefficients. There's x plus y to the 6th power. Pascal didn't make up the binomial theorem. He's the one who recognized that his triangle consists of only binomial numbers.
So the N choose R thing applies to the 4 choose 2 equals 6, 5 choose 5 equals 10. Is that what you're saying? Like the space in between?
Yes. Well, no, 5 choose 5 would not be 10. 5 choose 5 is 1.
Yeah.
Right, 5th row, 5th entry is 1. You start with 0. 0th row and 0th entry. Right, so this would be 5 choose 0. Then 5 choose 1. 5 choose 2. Choose 3. Choose 4, and then choose 5.
Y. All the like extended ones. There you go.
X starts with the highest power. So whatever it's being raised to, that's what X starts at. Y starts at 0. For each term, subtract 1 from X, add 1 to Y. And you just keep doing that until you're left with Y to that power, which in this case was 6. Right, and then your coefficients would be just go down to the proper row. In this case, it's to the 6th power, so we go to row 6, and it's just that order.
That's why you want that phase.
Yeah. Right. So that is how I got that x plus h cubed so quickly. Just an application of Pascal's triangle and the binomial theorem. I will pick up here on Wednesday. I'm sorry? Yes, so shortly after class ends, the recording posts. On Teams, yes.